Hello everyone, today I'm returning to the subject about thinking in systems and I will talk about feedback loops. I really like to talk about this subject because it's like going to the gym. We stretch our mind, we abstract the way we see things, and we start to see that there are a lot of comparison between the IT and no IT, meaning that, and if you are following my previous videos, you understand that our life, our professional, behind everything there is always a system, and if we understand that system we can optimize the system, we can detect bottlenecks, we can check how to improve it, we understand a lot of things about what's happening even in the world. And I'm not exaggerating. If you see my previous videos about thinking systems, or if you start to study this area, you will see that what I'm saying is true. And I'm introducing this subject, the thinking in systems, in a, let's say, generic way. Of course, half of my slides will be about IT, software architecture, or the regular software engineering. But inside the subject, later I will provide other videos target specific solutions, architectures, like similar to those books where you see that you can buy about system design, where you prepare for interviews about how to design a system with a load balancer, how to implement a search, what are the best strategies, why you should decide something like this or not, consider the number of users, and so on and so on and so on. Behind all of this, if you understand architecture, and I'm creating a set of videos about how to be architecture, I think together with the thinking in systems, I think you can find great solutions and think for yourself what are usually the best answers to those questions that arise. And not only for interviews, but even probably in your daily work, you start to understand what an architect is saying. But if you are an architect, you start to understand better the system and how to map it to real components. Okay, but let's go forward, not only about introduction, but I just want to explain the scope of why I'm creating this, because every time I create also these videos about thinking systems, it stretches my mind also. It makes me learn, makes me remember sometimes things that I know, and to be very fair here and transparent, sometimes I learn when I'm building these videos. I think when we share and create things for the others, we learn a lot. I think there is a theory about this. I don't know if it's the learning technique from Feynman or something like that, that says that if you want to learn something, teach it. So today, as I was saying, I will be talking about feedback loops, and those will be about reinforcement and balancing. And let's see what they mean. From the name, I think you can get or start to have an idea what I mean by this. So what are feedback loops? Feedback, you already know what is feedback in any system, and when a system, not being technical, in a system in sound, and hey, please give me feedback later. And you understand when you say this that a feedback loop is a cycle where a system output affects its future input. And that's not casual. When you say something, okay, then give me feedback later about that. It's the definition of a feedback. And this definition applies also on the technical point of view or the science point of view regarding systems. So why it matters? Feedback loops explain why things go wrong, shrink, or stay the same in real life and software. That's what feedback loops try to explain. There are two main types of feedback loops, and these are the two that we'll be talking about. One, it's reinforcing, amplifies change, like a snowball rolling downhill, meaning that you have something, you have a system and you have a kind of a stock. And when I say stock, if you saw my previous video, it can be your bank account, it can be a thread pool, it can be a connection pool, something that can shrink or can grow and decrease. There are some value associated. There is a metric. And the reinforcement, the name is already saying something. It amplifies the change. This change can be growing or decrease, but somehow affects what's in there. But the idea of the feedback loop is that it starts in itself. It's not something that comes from the exterior part. It's on itself. It's like when you have a bank and you have interest in an account, you don't have to provide nothing. Just the time is goes right every month or on a, let's say, 6 month or a year base. your account starts to increase its balance because you receive interest on the money that you have there. And then you have the balancing, which reduce changes, like a thermostat keeping a room at the right temperature. So you have reinforcement, but at some point you say, okay, you should stop. If you are in a specific place and let's say there are 15 degrees and you put your value on the 20 degrees, you need a feedback loop that reinforce, meaning it should warm, it should give hot water, not air, to the room. Water, if it was a swimming pool, but in the room. And then when it reaches 20, you want to make it stop. You don't want the reinforcing constantly. You want to say, okay, stop. Now let's balance this. And there's, of course, there are different strategies to balance this. One of them is just to stop to inject warm air. But it doesn't mean that stops at 20. Maybe you want to put some fresh air, or maybe when you have some kind of artificial intelligence, when it reaches the 18 and you know that when you stop, at least the temperature grows 2 more degrees from history data, and then you start to balance your system. You don't allow it to reinforce. You switch off the reinforcement and you just start to balancing. That's how this works. And this same applies in software. Sometimes you have reinforcement requests coming to your thread pool. Let's say it starts to grow, and you have to scale and just to reinforce. But at some point it will reach the limit and maybe start to throttling. You say, okay, now I have to stop. I can only allow, let's say, 10 connections per minute or something, because there are a lot of connections that I'm handling and my system, it's on the limit. And you don't want to break the other connections. You don't want your system to be slow, so you just starts to balance. It's like the temperature. Your system starts to get warm and say, hey, enough, now I need some fresh air here. Okay, that's the same concept. Okay. So parts of a feedback loop, you have the stock. Stock, it's the thing that change, okay, that builds or up or reduce, like money in a bank account. How fast stock change, it's the flow, like the deposits or withdrawals. And then you have the feedback, the cycle that connects the current state to future change, as we talked about earlier. So let's see a simple example. You eat more, you gain weight, you get hungry, you eat more. And this is a system that usually it's quite popular, unfortunately, sometimes. So what is the reinforcement feedback loop? Now let's go on specifics here. So simple definition, a loop that keeps increasing or decreasing over time. So you have a system that it's stable and it goes increasing for some reason, like in an interest account, which is a good example and great for us, right? But you also have the opposite. Maybe the system, it's always decreasing. Imagine that you have a place where you have a lot of water, a reservoir of water, and then there is no rain. So there, it starts to, the water starts to go out. The sun and the usage of the water starts to go out until it will disappear. So a common sign, things get out of hand. They grow fast or fall apart quickly. That's the reinforcement. Because here the reinforcement, and maybe my example was not so great, because the idea of the reinforcement is that you have some kind of quantity that you increase, and then the next increase will not be linear, because you have a specific stock or specific value, and then you add something, and now it's all this something that will be now the initial value where the reinforcement will be applied. So we have 100, for instance, now you have one, and you apply some percentage on it, let's say. Now you have 150. Now it's you have 250, that where the things will be applied. So it can be, I wouldn't say exponential, but it can happen, but it's not linear. It grows faster and faster and faster. And the same applies on the other way around. So the key word is amplify. Don't mean that amplify positively. It can go up or down. That's what can happen. So real life feel like when something goes viral. Okay, it's a feeling that we have. We have one person, then 10 persons, then it starts to spread the news, and in a few minutes, it seems like the whole world knows about it. It's like a big news. It starts on a simple place, and in a few minutes or hours, it's spread all over the world. So that's because there is something reinforcement feedback loop there. Maybe there are influencers or people that reinforce the system. That's what's happening. So, but again, you can always see the stock and the interest. Meaning you have 100, then when 105, now the stock will be 105, but the interest is the same. So the growth will not be the same. It will be a little bit more. At start, we don't see the big difference. but will be a tipping point when it starts to make difference. And the same applies in software architectures and solutions. That can be that's the mapping, and that's as I said previously, it's one of the reasons I create these videos, because there's a big parallel. It's the concept, it's the way we think about things. Okay, real life example, compound interest. It's something that we already talked about. So your money earns interest. That interest earns more interest. That's what I talk about reinforcement. So your money grows faster and faster. And you can see, if you use the formula for that, you can see that it's always this exponential, that as the time goes, and you are always adding the interest from the base one. And of course, it will be quite intuitive to understand that it's not linear. It will start to grow easily, but then it will be quite strong. So in the visual loop, you have money, interest, money, more interest. So money, more and more squared, and things like that. I think you understand what I'm saying. So another real life example, social media fame. It's the same concept we already talked about. You have followers, you have more likes and shares, you have more visibility. So if these people start to share your things, it's not linear again. You share with 2, these 2 share with other 2. So we have 4 and then 8 and 16. Of course, it's not in this proportion, but I think you understand the concept. It's the same thing. And learning and confidence, even when we apply this to us, the way we learn things, it's something. If you study things, you say that at the start there is let's say, big stone that we have to move out from our life. We have this laziness that it's crazy over us. But when we start to do it, we feel more confident. We try harder and we learn more. And when we learn more, again, it's like an interest on a bank account. On the software side, it happens the same. I remember that once I was starting to work in a startup company, and there were no CI/CD deployments, there were no DevOps and things like that. And the first time we start, it's like you have a bank account with just small portion of money, and you want to add interest on it. You want to create this pipeline, but you start with small amount, and you gain some interest. You automate just a part of what you're doing, and then people say, okay, maybe this can be a good thing. And then you start to automate more in a second iteration. Then you start to reinforce this. You start to create better scripts, better deployment strategies, things like that. At some point, you gain a lot of interest. And it's not linear. It's not like maybe you take 2 or 3 weeks to have your first CI/CD good one that can fit with every team, the testers, the designers, the people that are managing things, the people that want to share the binaries with customers, things like that. It takes a while, but after that you start to earn more. The profit that you have after you build this will be more. So your stock starts to grow. Let's say you have this reinforcement, and it will be about the motivation of people. The reinforcement, the feedback loop here. It's the people motivated to make that thing, the CI/CD better. So they start to create others to automate other things, and like that. So you have frequent deployments, faster feedback, better fixes, higher confidence, more deployments, and it will benefit the whole process. In the software, this happens a lot. And I think if you check somehow these kind of a feedback loops, you can see them when you think about agile. You have this reinforcement, because the idea is for you to improve your team and the performance of your team, and for that you have some ceremonies like spring retrospective, spring review, good planning, and you start to increase or make your strategies about management better. And then the stock, it's the same, but you are receiving interest over time. It's almost the same concept if you think about it. So if you were, for instance, an IAter in the data, and this is even if you are not in the area, I think you will understand the example. So you have users interaction with the system, and you want your system to gather some intelligence or starts to behave, let's say, with the current trend about AI. So you take raw data, logs, inputs, and other types of information. You clean something that maybe it's not useful for the AI, and you train the data and you create a model. Now this model tries to predict and try to recommend actions, whatever it is. And if they are good, they will influence user behavior. So the user starts to use the system differently. Maybe it will be faster. Maybe it doesn't have to click in a lot of buttons. Maybe the system can guess what should be the next screen or the data that should be displayed. So you provide indirectly or implicitly some data to the system that assures the system that is going good. Or maybe it can influence to do better things differently, the way you click things on a website, whatever you are trying to teach on your system. So again, you are generating data, even if there are logs or clicks or whatever maybe. So again, you receive this data and you inject on your model again. So the model will increase better and better because you're reinforcing the system with data and behavior, so it starts to grow. That's what we talk about. Feedback reinforcement here. Or maybe the system is not working well, it's failing. And for that, we'll need something that we'll talk in a moment, which is we need to balance the system. We say something, okay, you predict, but it's wrong. So I have to do something about my model. Again, it's like when you reach the temperature in your room and you want to make sure that, okay, it's enough. Stop the reinforcement because it's not working. Now we should put some fresh air. It's the same concept if you think for a while. You have something that push the values up or down, but then you need another feedback that say, hey, okay, that will trigger to balance the things. Okay. So let's see another example like feature virality. It's the same concept as the social one. I didn't want to create a big difference between the examples, so because I want you to capture the idea of the feedback loop, meaning the reinforcement and the balance. But it's again, we have new users, more shares, more invites, more new users. It's like if when you join an app and it's an app that you want to sell or a website, and there are a lot of strategies if you think for a while that they use this system. Maybe it's by invite and they propose the users, maybe you want to share and you will gain something, so these people will be, okay, I want to share, so they will reinforce indirectly your system. It's a strategy, for instance, used in sales to promote a product. Okay, it's another area where you can employ it. But if you think for a while, it is the same concept, it's the same system. You have something that you want to reinforce. It's always this cycle. That's a feedback loop. But this specific one, it's about reinforcement. That's the idea that I want you to capture from this video, even though I really know that I talk a lot sometimes. So now the reinforcement loop summary that we have been talking about. So core idea, small inputs can lead to exponential outcomes. The growth, think snowball effect or viral growth. Some caution here, and check the reinforcement can spiral out of control, leading to crash, bubbles, or burnout. Even in a system, be careful with that. Used when you're designing for growth, momentum, or scale. That's when you think about reinforcement, network effects, viral product loops, machine learning feedback cycles, and there are a lot of examples that where you can apply this. If you capture the idea, I think you can quickly see, okay, my system here, what's happening here is a reinforcement of something. Because I have some value here, whatever that is, computer, no computer, real life, bank, even relations, anything you can put here, and there is some reinforcement here. Imagine some strange, like let's say young people, teenagers, sometimes they have a lot of gossip and things like that. It's a kind of a reinforcement. They don't like someone, and then someone says something, and they capture this idea and start to reinforce. I see this, for instance, in comments about soccer teams and things like that. It's the same. Something happens, and then a lot of people that like a reinforcement loop. The subject is the same. Nothing changed from the last weekend, but there are a lot of people always reinforcing. At some point, it seems that a small thing started to be a big, serious thing, and it was just maybe something that usually happens. That's and when you see this, you say, okay, there is some reinforcement here. Maybe someone or entity should come and say, okay, let's start to balance this. Let's reduce the temperature in this room, meaning the temperature here, the values that start to be out of control. So now let's see what is balancing feedback loop. Until now we talk about reinforcement, but sometimes you need to put some fresh water, fresh air, stop what is being growing too much. And the simple definition is a loop that keeps things stable, like cruise control. So okay, I want to control this. Okay, at some point I want to control this. And all the systems usually need both. Unless you say, okay, it's my money bank account, I don't want a balance there, unless it is going down, but if it's growing, I don't want, fair enough. Okay, I'm also want that too. Goal, maintain a set of point or equilibrium. That's the idea, and common sign, system resists change. You know that there's some kind of a limit, and you know that it's being controlled because, okay, I have this let's say, flow of users, of requests, but my system stop at a specific point. It's controlling what's happening here. It doesn't accept the activated throttling. It removes some features because the CPU was too wide, so I created feature toggling, and it's a thing what I'm saying. Sometimes you have 100 features on your website, but there are 20 or 30 that you say I can remove them from the website temporarily because it is becoming too slow to manage on the website. The resources are quite high, and I cannot handle all these resources. And usually you choose resource like ads and things like that they make the CPU go high, and they don't provide any direct value about your business. It's just an extra, and you start to remove these ones temporarily, and then the CPU goes down maybe 40%, 30%, 50%, and then you start to activating them again. What's happening here, you have a reinforcement. It was the access to your website, and now you need a balancing feedback loop to make sure that you, let's say, you put some fresh air, even if you have to remove things. Maybe the solution is just to scale. If you are in a Kubernetes software thing, or add another server, if you are using a different technology, I have to start another virtual machine, I have to start another container, I have to duplicate things, I need to tell to the load balancer, now you have one more or two more or three more until there is a certain point. That's the way you want to balancing. Why is balancing here when you scale? Because the reinforcement still continues. You are balancing the resource of a specific machine by duplicating or cloning this machine to another one. That's what I'm talking about, the balancing here. Okay, balancing is not just stop things. It's to stop in a specific context. Okay, so, and this is just an example here with the temperature and the sensor. And I know how it works. If you have air conditioning in your room or in your work, you know how it works. It starts to grow, and when it reaches a temperature, then it stops, or maybe change a little bit the air, starts to put some fresh air and things like that to make sure that the temperature is around the value that you targeted at first. So real life example, thermostat, the one that we already talked about, room too cold, heater turns on, room warms up, heater turns off. This is a balancing feedback. The heater turns on, it's the reinforcement that is being applied to reach a temperature. But then the other one should be triggered so it can balance and do not go out of scope or out of the interval of values that you want for the temperature. Body temperature, our body is doing this when we are doing some gym, running, or efforts and things like that, or maybe in other contexts, like when you have, let's say, hot weather, for instance, and we get hot, we sweat, the sweat makes us cool down, and we stop sweating. There are, of course, the human body, it's more complex than this one, but it's a great place to study these systems. Even water can work as a balance loop, a feedback loop. Okay, I'm just hitting some words here. Even the water, when you drink water, it calibrates our system to handle better the increase of the temperature and things like that. Okay, even ice when we are sick, to decrease our temperatures. There are manual ways and automated ways in our system, our body, to create this balancing. Okay, real life example, anger and heating. This is quite common. It's very simple. I just put here simple examples so you understand that these systems are everywhere. So we have hunger, we eat, we are full, we stop eating. And that it's a kind, while we are free, there's a reinforcement. We reinforce the system with food. But at some point, there is a trigger say, hey, you are full, don't eat more. And we start to balance. And if you push too much, our body has ways to say you should really stop now, okay, as you know, and I will not enter into details here. So another software examples, I like to balance these examples. Caching and eviction. Caching, it's a quite good example because when you start your cache, it's empty or maybe half empty, depend on the way you are developing, but there will be a reinforcement. But then you have caching strategies. And if you think for a while, caching strategies are nothing more than balance feedback loops, because you have strategies to say, okay, it's reaching the limit, so we have to eliminate something here. So we have to balance, so we have space for other cache in the future. Maybe we start to remove the oldest ones or the less used ones. There are a lot of different strategies in caching. And what you are applying is reinforcing. You are putting things on the cache to make your system faster, for instance, but then you need a balance. Otherwise, the cache stops to be useful for your system. And you have to balance these things with these two types of feedback loops. Kubernetes, I already talked about it during this conversation. The autoscaler, when I'm talking about, for instance, on containers. So you have a high CPU usage. You add pods because the resources start to be highly consumed. Then the usage drops and stop adding pods. So the Kubernetes, because Kubernetes works, it's a course per se. I will not explain everything, but Kubernetes works as a kind of a declarative system. You don't explicitly say that I want 4 pods in these conditions. You say something like I want between 2 or 5. And if it's first time that you are hearing about this, think as it's more than that, but think about the pod as a container, a Docker container. It's the same concept, but it's more than that because it contains configurations. And you can say to Kubernetes, okay, this service should be between 2 and 5 pods, depends on how the load balancer handles this. So if you have too many requests, you start with 2, then Kubernetes puts 3, 4, 5 until it reaches the limit. And if the number of requests starts to decrease, the Kubernetes starts to remove this instance. So it reinforces. Usually here the Kubernetes is doing the balanced feedback loop. That's what it's doing, because you declare the intervals. It's like a thermostat, not for temperature, but for the number of containers that you want to be running in a specific moment. That's the same, and depends on the temperature. And here the temperature, somehow it will be the number, or not the temperature, but the temperature increases as you receive more and more requests to this service. It's almost you can take this metaphor to understand. So you have CPU usage, high or low. Kubernetes monitors their usage, and yes, the autoscaler, and it will influence the number of pods. Or scaling down, reduce because the temperature is quite high or quite low, depending how you want to see it. So it reduces the CPU pressure. And on the other way around, the load balance spreads across pods, because if you have a lot of requests, so it has to increase the number of pods. And then it checks again the CPU usage and other resource and takes the decision, should I be with 2, 3, 4, or 5? And usually it increases or decreases linear. You say I have 2, now I have 3 containers, then I have 4 containers. I think you understood the concept. It's quite the same as the thermostat, if you want, somehow. That's why it's so popular, the Kubernetes, because it's declarative. You don't have to know in advance all the rules. It balances by itself. So, but behind this, again, it's just a feedback loop on the balance, a balanced one. Okay. So rate limiting or throttling, as we can call it, protects systems from overload, request load, and I already talked about in some previous examples in the slides. So you have a request load, volume of incoming requests. And the triggers when the request exceeds limit, meaning that there is a reinforcement of the system. You receive a lot of requests, and now you want to create some balance. You can just stop, cut. Maybe, probably it's not a good idea because people start to receive a lot of timeouts. But what you put is a rate limiter and say enforce limit on requests per unit of time. And you say, okay, no, I just receive 10 requests every 10 seconds or 20 seconds, it depends. Or even now I only receive requests for the people that are paying for my service. I know Netflix does these kind of things. They have different quality, let's say, or service level agreements, depending if you are, what type of customer are you? And that's a way to balance the system, because there are limits on their system and they want to balance it. It's you can also say, okay, more users, great for them, but they have limits. So it's not only about reinforcement. At some point, at some hours, there are a lot of people going, and you say, okay, I cannot provide this quality for the people that are paying less. So I will just provide the quality that they are paying for. So I will not allow this kind of resolutions. But if I have a low traffic, maybe I can offer that. And my services will be, let's say, will have a great marketing, because I'm getting something that I shouldn't, because I'm not paying for that. But I have to pay the price later when the feedback loop balancer is activated in Netflix, and say, okay, be careful, I will just stop that quality. You'll receive, let's say, full HD, the 4K is for other people. Okay, that's the concept here. It's the rate limit, but of course you apply this also to requests to a database, requests to REST API, and so on and so on. So usually by now, I think you understand that usually a good system, I don't say every time, depends on the system, of course, but from the examples you can understand that usually you want a combination of the reinforcement and balancing loops. At least for in software, we see this a lot. So why software needs both? Modern systems use both types of loops. Reinforcement loops to grow usage, features, and engagement, because you want to attract traffic if you are public websites, and we earn money from it. But we need also the balancing loops to prevent overload and ensure reliability and, of course, quality of the service. Otherwise, if you receive everybody and the system goes down, it will create a bad image and people don't return to it. So the balance here is as important as the reinforcement. So some real world examples: logging systems, more feature, more logs, more insights, reinforcement, but sometimes you need some log filtering because you have storage quotas, alert thresholds, and maybe we cannot deliver all the logs. For instance, in a city, I once worked in a bank, and I'm not exaggerating, they receive around 200 million messages a day. It was one of the biggest banks in the world. And of course, there are some logs that they will just ignore. They say, okay, the bug, usually in production, we don't want unless there is some problem that starts to appear. Otherwise, it will be just reinforcement and having all the information to try to control everything. It will be just craziness. And of course, they have this balance system to say, in these situations, balance the logs, just cut all these ones. They don't log them, they just disappear. But if there is an issue in a specific service, we want to activate that and check the detailed logs about what's happening, because it will be useful. Then it's again the way we want to reinforce them, because we need all the details information, but sometimes you have to balance, otherwise it start to put in cause even the reliability or the smoothness, if we can say like this, of the system in production. Commercial websites, again, more users, more reviews, better SEO, more users. Reinforcement, it's the dream, but then we need rate limiting, database, query cap, CDN, caching, and things like that to balance. Sometimes you have to cache things, we have to duplicate things. It's a way to balance our system to handle all this loading. APIs, more clients, more integrations, more traffic, higher value. We want that if you are receiving money, but we need throttling, retries, circuit breakers when it fails to make sure it's a feedback loop, balancing one, to make sure that the quality of the service it's stable, it's controlled by us. Okay, so always think about these two. Every time you have a reinforcement, for sure you will need one to balance, unless again if it's about our banking account and the reinforcement, it's going up. Okay, so spotting loop behavior in software, reinforcement loop symptoms: rapid increase in log volume, API traffic, user interactions. The more system is used, the more value and pressure it creates. That's how you detect reinforcement loops when something starts to grow. For this, of course, you need metrics you can use Prometheus and OpenTelemetry, things like that. I am creating a set of videos about that. So you for this you understand that you need metrics to check how is growing some service, maybe to put some alert, because if your system doesn't have a balance feedback and you only reinforcement, something that you're not expecting, maybe it's an attack from hacking, you need to create or have a plan to activate a kind of a balanced feedback loop. I don't know why I'm constantly mixing these words. Balancing loop symptoms: automatic throttling or flattening of growth. This is a good thing. It means that you planned well your system when you have a good balancing loop. Seen in API rate limits, storage retention policies. You can see this in the cloud. You pay these balancing things. If you go to the cloud, they say, okay, you have a lot of storage to use, but you pay less if you use storage that I don't make available. For instance, I remember that at AWS you have a kind of a storage that says, okay, if you don't use this for several months or 30 days, you pay almost nothing, but if you need it, you have to pay a lot. So it's like pushing things to other places. You are balancing the system, so the better hardware will be available for what's necessary and makes money. That's one of the ideas. And architect's mindset: if you are in software, ask yourself, where is usage triggering more usage? See, I have something, for instance, I remember that when if you study thread pools like fork join that is used by Java, it's a way that you have a thread and this thread can split into or fork or process. It's quite easy to understand this is a feedback loop reinforcement, okay? And where is the system pushing back to protect itself? Maybe you have a limit and say, okay, my thread pool, I allow them to grow, but I have a limit of 100 threads. So that's your other feedback that will trigger and say, okay, no more threads here. You have to work with only these 100 that were specified. So designing with dual feedback loops, that's the idea. So identify feedback forces, like what features or behaviors encourage more use. That's one way for you to look into the system. And what controls or constraints prevent system overload. So again, how to identify the two forces, one that makes increase or decrease, and which one says, okay, let's trigger the fresh air here because it's necessary. But of course, these two are quite related, as you may understand. To find safe boundaries, logging and log sampling, rotation limits, the things that we explained, just a summary. E-commerce, cache product page, cap personalized depth, APIs, apply quotas, fallback response, timeout strategies. I think by now you understand what are these feedback loops and why these things exist in the systems, in software. You have, okay, we have this scaling mechanism, great, but we have quotas, we have different prices, we have throttling, and you can configure it as you want. What they are saying, okay, this is a system that it's a reinforcement system because you accept requests, but it's on you to define where do you want to balancing it. And you will balance it, align it with your business requirements, with your business expectations. And that's what I think it's a summary of this video that I'm creating here about the feedback loops. So monitor and tune loops, reinforcement loops can create log storms, request floods as expected, and balancing loops must react fast enough to avoid instability. This is quite important. When you create a reinforcement loop, a reaction to something that is happening in the system, you want to measure how much time it takes. Imagine that it takes more time than you expect, and during this time the system crashes. So you have to align and to say, I want my CPU to not, let's say, pass 90%. So I take measures when it reaches 60, for instance, because my system takes 1, 2, or 3 minutes to to scale, to let's say, to alleviate the CPU one, while there will be another machine to handle now the new traffic. Be careful with that. There is this gap of time that you should consider when you plan the system. It's not that, okay, I have this system, it will duplicate. But if it takes a lot of minutes, the other one already went down, and that's a problem. Okay, takeaway, every growth system needs a governor, designed for scale, but architect for control. Okay, design for reinforcement, but architect in a way that should be easy to balance the system. That's what I want for you to know about this video. So common problems in balancing loops. Delay in feedback, that's what I was talking about. When corrective action kicks it too late, that's what we were talking about. Or overcorrection, too strong of a response can destabilize the system, causing oscillations or inefficiency. Imagine that you had say, okay, when it reached 100, I just cut. And then when it goes down, it's open. So it will be just, you see some up, down, up, down, up, down. It's better to start to, let's say, if you have 100, to reach 80, and then you throttle the system. So you start to reduce. So you have time, you have a gap of time to control the system. So it will be smooth, rather than have highs and lows, you have a kind of a smooth wave about the request that you are receiving, or if it's not request, if it's another thing, it's the same concept. So let's say a real example, an inventory system overorders stock due to lagging sales data, leading to surplus, waste, or cash flow issues. That's the same problem with an inventory in a warehouse. If there is a big gap of time to sync the orders and what is deployed, so when you are doing the order, it takes a lot of time to receive the information about what is the current stock in the warehouse. It can be a problem. Then a lot of orders will fail with out of stock because it took too much time to balance the system. That should be a warning when, for instance, the stock is 80%. So someone could see. Imagine that you are close to Christmas or other holidays that sometimes they create these waves of buys and orders. That's one of the things that you have control. And again, I return here to this takeaway: design for scale, but architect for control. That's I'm saying a lot of things, but at the end of the day, that sentence defines everything that we are saying. So if you want to diagnose feedback loops in systems, again, reinforcement systems, fast grow or collapse, balancing systems, slower changes, oscillations, and plateaus. That's what we want. It's slower changes, draw out the loop and look for what affects what. Okay, if you want to combine, again, more examples, combining reinforcement and balancing loops. Real systems have both grow, push forward, limits, push back, and balancing. So in conclusion, feedback loops run the world from your body to your code. And I think I show you that. And key learning, reinforcement, grow or collapse, balancing, stability, and control. Your job, learn to spot them, shape them, and fix them. That's what I want to tell you about this video, the feedback loops. I repeated a lot because I really like watching this video to understand the concept and the paradigm. Sometimes we say 1, 2, 3, 4 times. At the end of the day, I think we understand. There are feedback loops, we have reinforcement, and we have balance. And I'm sure that you start to see the world differently, your software differently, even your meetings, relations, and things like that. If you think for a while, there is some reinforcement there, and there is some balance. Even when we talk with people, the relations, social relations, we accept a lot with friends, but then there's some boundary, and sometimes we came with the balance, say, hey man, don't talk like that. Don't talk about my wife or my daughter always that way. Or even to our family, we sometimes put some balance there. And this is, if you think for a while, we are constantly with each other in feedback loops. So I know I took a lot of time in these videos because I know that I talk too much, but I really hope that I taught you something that you can apply in your life and is making your brain see things differently. And I hope that you start to be at least a better professional in the IT industry. So again, thank you for watching. Share with your friends. Check my other videos with different subjects in the area of IT. Provide comments, give me ideas, and thank you for watching.